Well, let's get started. We are going to talk about an interesting topic. At the Global Azure LATAM, this talk had a different name, but this time it is going to be called Creating Amazing Experiences with Arduino Azure Unity. My name is Hector Perez, as I have previously mentioned in different live sessions. I am a Microsoft MVP and also have a course academy called El Camino Dev. If you have any questions, doubts, or comments, you can send me a message at hector.elcamino.dev, which is my contact information. Okay, we are going to discuss the purpose of this presentation. The aim is to create experiences, or give us the notions to create experiences, as we see here in the background of this slide. We see that we have an experience, or remember in the Iron Man movie how Tony Stark interacted with different holograms on his desk, could manage the different screens, touch screens, get information, etc. So, the goal is for us to imagine a world of that kind, to be able to gather information through Azure and present it through a Unity-based application. We're going to talk a little about the components of the application to give you an idea of how the application will work. Firstly, we need an Arduino, but an Arduino does not work on its own. It needs sensors that obtain information from outside and basically continue reading this information to fill a database. We will also need a console application, which will allow us to connect to a service. In fact, the service consists of Azure functions, a function app. For those who don't know, a function app is essentially as if you had a function in your C# code or in your code from another programming language, and you only upload that piece of the function to the cloud, and you could consult that piece of information whenever you wanted to carry out different operations. Finally, we will have a Unity-based application that will once again allow us to connect to a function in Azure, which enables us to read information that we obtain from an Azure service. Let's begin with Arduino. Basically, Arduino allows us to generate data. To carry out this action, we are going to need something called sensors. The sensors in Arduino allow us to read external information. We have an infinity of sensors that we can use with Arduino. Here we have a small list of the components that we can use that range from sensors to measure temperature and humidity. On the left side, we have a relatively simple sensor, and on the right, a slightly more complex sensor. These sensors allow us to measure temperature and humidity, but we also have light sensors, for example. Again, on the left, we have a more straightforward sensor, and on the right, the same sensor, but with some slightly more complex components. We also have sensors, for example, to measure a person's pulse. This is a rather interesting sensor that we could also use for an application of this type to monitor a person's heart, how it is, if it is okay, or if perhaps it has any kind of problem, monitoring it from another place in a very simple way. We also have sensors like microphone sensors, which can help us detect different things. For example, if a loud noise is heard in an area where there should be no noise, we could already know it with this kind of sensors. We have tilt sensors. Well, we have a lot of sensors that we can use. These sensors are just to give us an idea of what we can do. Basically, for this specific project, if you wish to replicate it, we will use some specific components such as a protowart, as well as a DHT11 sensor with PCB, that is, with the small board that we have in the background. Remember that this sensor will allow us to measure temperature and humidity. Also, a photoresistance sensor with a PCB like the one we see in the image. Obviously, the Arduino Uno, which will be the board that allows us to carry out the reading of different data. A set of jumpers will allow us to make the connections in our circuit as such. Okay, so we see that the connection for the DHT sensor is really very simple. We see that we just connect 3 cables as such. We have connected our Arduino with our sensor, and to connect our photoresistance sensor, we also only connect it this way. The blue cable is connected to the A0 pin for analog readings, and the pin connected to the ground, and the pin connected to 5 volts. We see that the connections are extremely simple with no complexity. Now that we saw how we can assemble our circuit, let's quickly move to the sketch. A sketch is a program that allows us to program or code our Arduino. So we basically have here a clean sketch, and I will copy here some snippets to make this a little faster and not spend so much time coding as such. The first snippet I have essentially indicates what the sensor pin is. In this case, we specify that it's the analog 0 pin. We initialize this serial.begin, which will allow us to activate a tool called the serial monitor to view or print what is obtained from the sensors. Lastly, we have a loop method, which is one that cycles over and over again, carrying out different readings. We declare a variable called light intensity, carry out the analog reading of our pin as such, the pin we indicated as the 0 pin, and finally, we will print the light intensity. We will indicate that we want to upload to an Arduino Uno board on the COM3 port, and we'll quickly upload this sketch to see it work. So leave OK, we see that it's uploading our sketch. We start the tool, which is the serial monitor, and we see that we have various readings here. If I put my hand over the sensor, I don't know if you can see. In fact, let me see how the transmission is. Well, I don't know if you can see right now, we'll leave it pending. But if I put my hand over the sensor, the quantity, the data as such, begins to decrease. This means that there is less light. If I remove my hand, the number increases, which implies there is more light. So, with this, we have a correct reading of our light sensor. Subsequently, we will proceed with the reading of the HT sensor to read temperature and humidity. For this, we need a library. We can go to the Tool menu, Manage Libraries, and here we have installed a library which we can search with the letters of HT. It's a bit bigger, okay. And here we installed this library called DHT Sensor Library, developed by Adafruit. In my case, the installation option does not appear because I already have it installed, but if you want to do this like I'm doing, you can install this library, it will save you a lot of work. Okay, now that this is ready, I'm going to proceed to add the code specifically related to this library. I include the library, indicate that the pin is connected, or rather that the sensor, as such, is connected to the pin number 2 of the Arduino. I create an object of a class called DHT, which receives the pin number and the type of sensor, because there are different DHT sensors. There's the DHT11, I think there's E12 as well, E13, etc. This is how the numbers change. Next, I indicate that I'm working with the DHT11, and after that, I'm going to copy my code here to perform the reading. I'm going to remove this line, and basically I'm going to create a series of variables that will allow me to directly read the humidity, the temperature, and the temperature in Fahrenheit degrees. We can see that obtaining these values is extremely simple thanks to the library we installed earlier. We just have to invoke the method, or rather the function readHumidity, readTemperature, and readTemperature with the value true. We check that if we do not get any sensor readings, then there is some kind of error in the sensor reading. Otherwise, we calculate something called the heat index of temperature and humidity. With this, we obtain the heat index in Celsius and Fahrenheit degrees. Finally, we perform the printout through the serial monitor as we did earlier. Let's quickly upload this sketch. Okay, the sketch is uploading. Uploaded, we go to the serial monitor, and here we have a small error in the sensor reading. Let me see if I can fix it quickly. Okay, it was a poorly connected cable. And here we have another problem. Okay, there it is again. Good, there was it. Basically, we see that we are reading the different data from our sensor in this format we see here. I'm going to turn off auto-scroll so we can focus on one line. Here we essentially have sensor data such as light intensity, humidity, and temperature. We see that I am at 16.30 degrees Celsius and 61.34 degrees Fahrenheit, and the heat index feels like 18.42 degrees Celsius. So with this, we are accurately reading our sensors. Once we have done this, we can add what's called a relay as part of our code. This way, the reading is somewhat more spaced out and not as quick as we saw in the example. So with this, we are indicating that there should be a reading every 5 seconds. I'm going to quickly upload the sketch to my board. Okay, I open my tool again to see the reading data. We have to wait 5 seconds. We have an error here in the sensor reading. Okay, let me fix this quickly. This is a minor issue, technical problems of online sessions. Let me see, the problem is that I had the circuit assembled and I disassembled it after the talk. Let me quickly increase the delay to fix this. Well, there we already have the data again. Well, I have demonstrated here that we are reading the data every 5 seconds. We'll get back to this shortly. So, we essentially have our coding for reading the sensors. Now, we have the information or the data. Where do we store this information? Let's go back to the slides and see, or if we remember, we had the Azure service where we could store the information. Basically, what we are going to do is to use an Azure function that will allow us to save information into an Azure storage table and retrieve the information to present it to anyone who wants to read it, in this case, the Unity application. Let's quickly look over this Azure Functions project. Firstly, I have a project here named Data Functions, in which I will close these tabs, and I have an Azure function. Well, first, how is an Azure function created? We need to have the Microsoft Azure workload installed to use this function in Visual Studio. Once we have this workload ready, right-click, Add New Azure Function. We have the Azure function template available here. We have different types of Azure functions. We see that we have, for instance, different triggers. A trigger is an activator that will execute our function when something happens. For example, we have a time trigger, which will activate a function whenever a certain period passes. We have an HTTP trigger that whenever a specified type request, an HTTP request, is received, the function will be executed. We have many types of templates that we can use for different services. For example, if we also want a trigger to execute when a change occurs in a blob from our storage account, we can also configure our trigger here to do something. In our case, we are going to use an HTTP type trigger since we want to send information to the database through a POST request and we want to receive information back through a GET request. So I already have here an Azure function that is called addData. We have it here. Basically, we carry out the configuration of our function here. We indicate what is the name of the function, which in this case is addData, that we want to work with the Azure storage service. In this case, we indicate that the table is called weather, and we have a connection called storage connection, which we have established in the local .settings.json file. In this way, we can test the service locally without needing to publish it on Azure. I already have it published on Azure for demonstrative purposes, but in case we wanted to test it locally, it could also be done. Subsequently, with these lines that we have here, they are the ones we will use to carry out the publication of information as part of our Azure function. Basically, here we indicate that we read the body of the POST request we are receiving. We deserialize that body into a type of weather entity. Weather entity basically defines what the properties of me, or well, the fields of my table are. In this case, they are ID, device name, temperature, humidity, heat index, and light index. Possibly, since we deserialize the information, we add a row key and a partition key. Basically, partition key refers to a set of data that is found in a partition as part of our Azure table. The row key is the data that identifies each row of our function. Partition key can be repeated because it includes multiple records grouped in a partition, whereas the row key should not be repeated. That is why we added these two necessary data items as part of our storage service. Finally, we return the data. With this, we can store information easily. I have previously published my Azure function. I'll quickly show this. I have my storage account, which is called Comunidad.demo. We have the tables section here. I'll enlarge this a bit. I have the table called weather. If I go to the Storage Explorer, we see that we have our table called weather. I've already done some tests, but mainly we have each of the rows that we have been recording. We have the data functions service where we have two, well, there are three published, But in this case, I have published two Azure functions. I have this one called addData, which is executed through an HTTP trigger, and the status is enabled. With this enabled, I can start to send requests to begin storing information in my table of my service. Alright. The next step is to publish that information. However, after evaluating different materials to see how to publish information directly from the Arduino sketch, truthfully, I ran into some issues and decided to use a console application for publication or to make that post request. Since here from Arduino I had some problems and I was reading that I had some problems Arduino to carry out the execution of requests, POS, etc. So I better decided to have a console application take care of the posting part of the various registers. Besides the fact that with a console application you can use the whole net framework to do validations, to do other kinds of more complex things that maybe in Arduino would get a little bit complicated. So basically what I did was I created another project called DataSender. Basically, here with this project, what I do is I declare an HTTP client, indicate what the URL of my Azure function is. Here's the full URL. Diagonal API, diagonal addData, which is the name of the Azure function I posted earlier. What else do I have? Well, I have here a definition of a serial port, which is basically going to allow me to connect to the serial port. To read at the set speed of 9600, which is what I have set here. If you notice here, I also initialize the serial monitor to 9600. This is the connection speed. I have also specified the port name COM3, and finally I open this port. In other words, I'm opening the same console that I open when I click here, the serial monitor. I open this new window, but in a console application. Finally, I indicate that as long as it has a value true, we know that this is going to be executed because almost infinitely. Basically, what I do is read the line that I get from the serial monitor. I store it in a string. That's what I was telling you, that I have more potential with this kind of thing because I can control that. For example, I could modify the string, I could do some validations, compare whether a string is of a certain type and so on. And what I also do is replace, well, we're going to look at this later, but basically I have something called a replace ID to generate a new Git from my own application. Finally, I make a console.writeLine to see the generated result. Then I generate the content to send it via the HTTP request. Finally, I make a client.postAsync that I send to the URL byte content, which is really the content I want to send to my application or to my Azure endpoint. Finally, well, here we make sure that we have a correct code. And in case we have any problem, we will simply display it on our console. Okay, we have this ready, and the console application really gives us a lot of potential. But we have another problem that we haven't solved yet, and it is that if we remember from the Arduino application, the one we have here, the results we obtain do not have an acceptable format for a post request. The acceptable format is a JSON type format. So, thanks to people who work with Arduino, we also have a library available that will allow us to serialize the data we have from our sketch into the JSON format. We have a library that I have previously installed called Arduino JSON. And I include it through this line. This really makes life much easier because I'm going to copy another piece of code here. I will proceed to comment on this entire section, the serial.print, and I'm going to replace it with this code that we have here. What I'm going to do here is basically create what is called a JSON buffer. I declare what the length of my JSON string is, and I create a JSON object. And see how easy it really is to create a JSON object. I simply indicate the name of the JSON object and in brackets and quotes what is the property I'm going to add as part of the JSON document and then what is the value. In this case, I'm indicating that there will be an ID called, well, an identifier called ID and the value replace it. Another identifier called device name, which will have a value of HT22. Another identifier called temperature, which is going to have the temperature value that we read earlier, which is this one here. And so on, until we have all the information that we need. And with this, I am going to proceed to quickly upload the sketch so we can see the result, okay? It is uploaded. Okay? We have here again the problem of the reading. Let me see if I solve it quickly. This problem is that... Let's see. Well, there it is already, not touched it. Basically, here we are obtaining, well, the error came out again. But basically here notice that we are obtaining a string already in JSON format, where we have what is the data that we want to represent, that in this case is ID, and what is its respective value. Notice that we have a JSON format that is completely valid since we have the name of the property and the value of the property, then we have a correct JSON format. This we could send it already without any problem to our Azure service. That's what we're going to do. I'm going to close this console. I quickly return to Visual Studio. Since I'm reading a JSON string, I can now send it directly to my Azure service. So I'm going to proceed to, well, here I would just have a problem with the sensor reading part. Let me see if it gets corrected. It's a cable that's causing trouble. Well, it seems okay now. Let's hope that's true. I'll quickly head to my Visual Studio project. Okay, it's initializing the project. I chose the wrong project. Let me cancel it. It's the data center project. Okay, the project started quickly, the console opens, and I have an error reading the sensor again. Let me see, I'm seeing if I have another little cable here. Okay, let's try once more. I chose the wrong project again. Let me open the data center 1. These things happen, they happen. Let me see if I can swap this cable quickly. Okay, I found another cable quickly. I am going to change it. Good. I think there are some problems, so I don't want to spend more time on this because we'll be here all night. But basically, the console application really reads the information in JSON format to send it directly to the Azure service. Unfortunately, I have reading errors. Well, we won't spend any more time on this. Let's continue. The next step, once we have our console application established, we need to fetch the information from the database. We're already sending information to our Azure function, but we're yet to receive the information so that the Unity application can read the data as such. I'm going to quickly take a drink of water. For this, I'm going to quickly return to the Visual Studio application. I have another function here that is called getData. Basically, what we do here is we connect again to the Azure service. We establish the connection, which is the storage connection. The table is called weather. What we're doing here is creating a new query. Notice in the query we're indicating where we have the data or the partition key that's equal to DHT22, which is the data we're sending to our Azure storage table. If we return to our database as such or our table, we have here the partition key, which essentially groups all the information we've sent. We could have different types of sensors that we could identify with their respective partition key and fetch the information from that, all the information set from that device or the sensor we desired. With this query that we're indicating here, we're stating that we wish to receive all the data found in the partition key with this identifier. Then we'll obtain a list of the records. We convert it, or well, we're creating a list to store the information in this list. Then we will go through each of the results to add this list to each of these rows that we find. In other words, we address all the records. Finally, what we merely do here is we sort in descending order according to the timestamp. That is, the signature when the record was created, and we obtain the first record to get the last one we inserted. Eventually, we return through a GET request, which was that last record. We can quickly verify this with Postman. If we go to Postman, we have the location of this Azure function /API/getData. If we click on Send, we have the information of the last record we sent to our Azure service. So with this, we have a valid JSON document that we could consume from a Xamarin application, a Blazor application. In this case, we are going to do it through a Unity application. Okay? So once we have this ready or have published the function, what we are going to proceed to do is move on to Unity, which is the part that I find most interesting. And really, with Unity, we can do many things. I am going to open an application before opening the final version, so you can see how to do this simply. Let me quickly find the project and I am going to open it. Here it is. It's called Galdemo. Okay, we are basically going to use something called Vuforia. I don't know if anyone has heard about this framework called Vuforia, and we can quickly go to their website so you can see what it's about. You can search for Vuforia, that's how the tool is called. You can go directly to the site. We are going to vuforia.com. Basically, this tool allows us to create amazing experiences. If we go to the main page, we will see a series of demos that display what can be achieved with this tool. As I say, what we will see in this demonstration is truly a tiny part of what can be accomplished. We see that we have here, for example, that we can use some kind of special lens like the HoloLens to see creations with Vuforia. We can also view it on a mobile phone. We can view it via a tablet, for example, or with a mobile phone, with an iPhone. We have many uses that we can get from this Vuforia tool. The advantage of all this is that we can easily integrate it into Unity. So, if you want to research more about this, you can do so. I'm going to show you quickly a simple project that can be done with Vuforia. Okay, what can be done in Vuforia, or with Unity rather, is once you install the necessary components, you can right-click and you have here a section called Vuforia Engine, where you can add different types of markers. A marker basically is the point where you will point your mobile phone, tablet, etc., and it will create the experience. In 3D, three-dimensional, or the experience that you want people to interact with these elements. In our case, we will work with one of the simplest, which is image target, which basically allows us to set an image so that when the camera points towards that image, it displays what we have indicated. So we have our augmented reality camera. We can open the Vuforia settings. And you must add something called a license or a license key. You can find this on the Vuforia developers portal very easily. If you want to see it later in the questions section, you can also ask at the end and we'll look at it in more detail. Here, you can activate or indicate which camera you want to use for the demonstration. In my case, I have selected a different camera to avoid any problems or conflicts with the streaming application through which you are viewing me. The next step, once we add a Vuforia camera, which is this AR camera, we add an image target. In my case, within this image target, well, an image target is associated with a Vuforia database. I can quickly show you this as well. Well, I don't have it available here. But basically, it's a section where you upload images, and this set of images you upload, Vuforia indicates whether they are suitable for these experiences. In case they are suitable, you can download them from Vuforia through a link in the database, but already in a format available to directly use with Unity. Once you have done this, you can indicate from the image target which resource you want to use. Here it appears in the part of image target behavior from a database. The database is called GEL, and the image target is called Logo Global Azure, which I used in the demonstration of this event. So this image is the one that has been positioned here as we see in this Unity editor, and basically what I did was add a three-dimensional model called Toon Chicken, which is this chicken we see here. With what we have done, we can directly start our application within Unity, and what will happen is that I can now use my camera, my second camera that I have active here, to start seeing a printed image. Notice that I have the image, and once this image is detected, I can see the three-dimensional model that I put on top of this image, which in this case is this chicken we see here. Notice how the model is not a static model, but one that is in motion. We see this model looks quite good. We can zoom in the camera, and notice that we are not losing the image or the three-dimensional object we have here. but rather tracking it accurately according to the camera's position. This is quite interesting because you can create different types of experiences like fighters dueling from the popular movie Mortal Kombat to make a promo. You can place fighters doing some kind of battle there, and well, this is the most basic thing you can do with Vuforia. In my case, I want to create a type of dashboard where I display the information that I am receiving from Azure. I'm going to quickly change the image Let Me See to avoid any type of conflict. Okay. I'll start this demonstration. Here, the application is going to fetch the latest values from the database. Unfortunately, we don't have the latest data from the sensors because we had some problems there. But basically, we have this interactive dashboard and we can zoom in, we can move along the dashboard, and we see how this dashboard really does not lose the focus that we are giving it. This is a very simple demonstration of what can be achieved. I could make the dashboard larger if I wanted to perhaps make this dashboard appear bigger as such. I could increase the size, for example, just so you get an idea of how this works. I'll start the application again. Okay, notice how this dashboard I have here has gotten larger. You could create some sort of marker that took up, for example, an entire wall, and this would look much better. In this case, it's a simple demonstration that retrieves values from the database. The original idea was for the app to be sending information to the server and that this information would be being updated, but unfortunately we had some connection issues, but this is basically the idea of this demo I'm mentioning. To carry out this demonstration is a bit more complex than what we previously saw, as it does use what are referred to as scripts or really basic C# code. I can open Visual Studio to view the source code I have here, which works with this application. We see that we've defined the service URL, that is the URL of my Azure function. We have a few things here, such as the declaration of the type weather, which essentially conforms to the structure of my table in Azure. We start a coroutine to carry out an infinite execution of requests to the database. Essentially, what we are doing here is deserializing this weather object and updating the information in the text boxes as we find them. This code is a bit more complex, but the truth is, once you understand it, it isn't so complex because you can replicate what's stated here. You can copy and paste the code parts that interest you and start changing the various values. If you want a new sensor, you just add certain values. For example, here I have this section to check the light information. I make certain changes to display the photoresistor issue. It's a bit more complex, but as I'm saying, once you understand it, it's simpler. So this is essentially the demonstration I wanted to share with you to show the potential that this tool has, or the potential of combining three tools as I mentioned before. I invite you to experiment and explore this sort of thing as well. In fact, there were some demonstrations in which from the same light sensor, you can vary, for example, a 3D graph to increase or decrease the intensity, or with weather information. You position yourself and show, for example, a very large sun which is almost burning you, that you see it very large. If it is very hot, it looks like a cloud with storms. If it is raining, or well, the truth is that the imagination is the limit for this type of issues.